We're used to getting lots of questions here at Seashow Space, but this one takes the cake. The sun is mostly hydrogen and helium plasma, which means it doesn't have a solid surface. Instead, it has a photospheric surface. What would you see? As you approach the sun, the sky wouldn't look like the typical bright yellow ball. It would appear dark, dusty, and filled with glowing gas. If you were there during the day, it would look like a black and white photograph with a hazy atmosphere. All the colors would be washed out, and the sun wouldn't be shining. It would be radiating heat in every direction. Want to learn more about the amazing technologies developed for space that we use here on Earth? Check out the link below. The air would be so hot that it would feel like being inside a furnace. You wouldn't be able to see anything clearly, because the air would be filled with dust and gas. The only thing you'd be able to see is a hazy, blurry shape of the sun, which is the level below the visible surface where light can escape into space. You'd weigh several times more than you do on Earth. It gets as close as 4 million miles from the sun's surface. But even that's not close enough to answer our question. So we're left with more questions than answers. And then finally, you'd see the sun in all its glory, a massive ball of burning plasma. But it remains to be seen if humanity is willing to risk the dangers involved in such a mission. For now, the sun's mysteries are just that, mysterious and out of our reach. But you wouldn't be able to see for long. The sun's radiation would destroy your spaceship and vaporize you along with it. This puts the sun's real starting line at around 100,000 miles from the center of the sun, which makes the radius of the sun about 10 times larger than Earth's radius. But that's not the end of the story, the viewer asked, which consists of several layers. First, there's the convective zone, which extends another 10,000 miles from the photospheric surface. This is where convection currents transfer energy upwards, creating the granular texture we see when observing sunspots. Above that is the radiative zone, where energy is transferred by radiation. It's so dense that it takes about 100,000 years for light to escape. And above that lies the already mentioned corona, which extends all the way to interplanetary space. If we built a spaceship that could resist extreme heat, well, it depends. You'd need a spaceship that could withstand temperatures over 2,500 degrees Fahrenheit, about 1,377 degrees Celsius, and intense radiation. At those temperatures, most materials would melt or vaporize. Your spaceship would need a heat shield to survive the trip. And to make things even more complicated, the sun's corona is mysteriously hotter than its surface. The temperature rises from about 2,500 degrees Fahrenheit at the photosphere to a scorching 3 million degrees Fahrenheit at the corona. How close to the sun could we really get? It's a great question. Partly because the answer involves some amazing science, and partly because the sun is hot, like really, really hot. But let's start with what we know. The sun also has an atmosphere, so how hot would you have to be to survive a trip this close to the sun? And that's not the only hazard. Sun's gravity is significantly stronger, close to its surface. Your ship would need to move incredibly fast to avoid being pulled in and destroyed. And it's not just a one-way trip either. You'd have to slow down and come back up, which means facing all these challenges twice. But that's just the physical challenges. There's also the danger of solar flares and coronal mass ejections. Unpredictable bursts of radiation that can fry your electronics and mess with your navigation. Okay, let's say you made it this far. Finally, you'd feel the sun's gravity pulling you towards it. Now, the record for coming closest to the sun is held by NASA's Parker Solar Probe, which uses a special heat shield to protect itself from the sun's rays. It's possible that advancements in technology may one day allow us to get closer to the sun. It might seem like science fiction, but space exploration isn't just about rockets and satellites.